Let us discuss this example. So maybe this example is looking so much simple. Limit x tends to 0, x raised to x. Let us try to find. See, what will I do? I will call it as y. So let y is equal to limit x tends to 0, x raised to x. We have to find its value. But see, the problem is that if I put x is equal to 0 directly, what will happen? We will have 0 raised to 0 form, which is not defined. We don't know its value. See, then we have to go for L'Hospital's rule. But the problem is that L'Hospital's rule is applicable only for 0 upon 0 or infinity upon infinity form. And we are having something different. So that's why L'Hospital's rule is also not directly applicable for that. So what is the solution on it? The solution is that we have to convert this problem into 0 upon 0 or infinity upon infinity form. Then only we can apply L'Hospital's rule and we will have the final answer, right? But the question is remains same, that how to convert this expression or this example into that 0 upon 0 or infinity upon infinity form. The simple technique is, let us take log of both sides. Let us do that. Let us take log of both sides. So what will happen? So log y is equal to limit. If you take log, okay, it will go inside. So log x raised to x. Okay, so you know the property of log. I will write that property here, that log a raised to n is equal to n log a. This property I am going to use. That means whatever the power of a, we write as a front of log, okay, as a multiple of log. So the same thing we can do here. So this is equal to limit x tends to 0, x log x. Okay, so now if I apply the limit, what will happen? If I apply the limit, x is equal to 0 and log 0 is minus infinity. That means we are getting 0 into infinity form. Okay, what we want, 0 upon 0 or infinity upon infinity. We need to work more on that. So what will I do? Limit x tends to 0 log x. I will write this x as a 1 by x in denominator. That means x is in denominator of denominator. That means basically it is in numerator. Getting? Let us see what will happen if I apply 0. Log 0 minus infinity. That means infinity we are getting in numerator. And 1 upon 0 is infinity. Yes, we are getting infinity upon infinity form. So that's why we can go for L'Hospital's rule. So L'Hospital's rule says we have to take derivative of numerator. Its derivative is 1 by x. Derivative of denominator, derivative of 1 by x is minus 1 by x square. 1x we can cancel this x and this x. Getting? So what will happen? This is equal to limit x tends to 0. This 1 upon minus 1 by x. After cancelling 1x, I should mention here by L'Hospital's rule. By L'Hospital's rule. So now this x is in denominator of denominator, it will go to numerator. So this is equal to limit x tends to 0 minus x. If I apply the limit, you know that minus 0 means 0. So this is value of log y. Getting? What we have? Log y is equal to 0. Basically, we want the value of y and we found out the value of log y. Okay, our target is to find the value of y. So what will I do? I will take exponential function of both sides. Logarithmic and exponential, they will get cancelled to each other. These are just inverse of each other. So by taking exponential function, log and e will get cancelled and y is equal to e raised to 0 you will get. Anything, any non-zero number raised to 0 is 1 always. So y is equal to 1. So this is the required answer. Y means value of this limit is 1. Okay, this is the required answer. You can make a screenshot of it, then we will stop. Thank you. Bye bye.